Next, kita akan tengok 3.3 contention-based medium. So kita akan tengok sejarah dulu. Aloha. Kan? Okey, kemudian kita akan tengok CMSACA yang sebut tadi, Macau dan Macau. Okay. Nodes may initiate transmission at the same time, requires mechanism to reduce the number of collision and to recover the from the collision. Example 1, kalau kita pakai Aloha protocol, use acknowledgement to confirm the success of the broadcast data transmission, allow nodes to access the media immediately, address collision with approach such as exponential backoff to increase the likelihood of successful transmission. Saya nak tanya kamu, sejarah internet ni, wired dulu ke wireless dulu? Aloha kat mana Hawaii? Dia nak connect dua node, dia tarik kabel ke? Masa tu dah ada pandai pakai nak jalankan arus kat kabel ke? Ke pakai je existing macam radio kan keluar dulu kan? Telefon pakai radio kan? Walkie-talkie radio. Lepas tu Morse code dua-dua boleh, pakai cahaya boleh kan, laser tu kan, pakai laser, and then pakai sound pun boleh kan, through sound pun boleh kan. So bila cahaya boleh Morse code, kamu boleh buatlah pakai fiber kan, pakai cahaya kan. Tapi dia kena hantar letih sikit lah, A dia berapa kali titik kan, A berapa kali titik untuk Morse code. Dah tu dah lain lah. Kita pergi kita tengoklah nama pun Aloha kan. Aloha ada dua, kemudian kita ada slotted Aloha protocol kan, protokol di upgrade, ada slotted Aloha protocol, require the station may commence transmission only at predefined point in time the beginning of a time slot dia tambah yang ni. So increase the efficiency of Aloha and introduce the need of synchronization among nodes. Right. Two forms of contention that are heavily used in today's network are carrier sense multiple access with collision detection. Yang ni kita dah pakai dekat wired kan. And carrier sense multiple access with collision avoidance, CSMACA. So CSMACD is used by Ethernet network while CSMACA is used by wireless network. Okay. Ethernet 802.3 kan? Belajar kan? 802.3. 802 ni apa? 1980 Februari. Dia sebut 802. Alah macam cerita 911 lah. 911 tu maksudnya tak sama. 911 11 September kan, salah. Tak sama, pakar. Okay, yang ni 802.3. Okay, dia punya standard ni sempena tarikh bulan dia Februari 1980. Okay, so dia letaklah standard point 1, point 2, point 3. Point 3 Ethernet. 11 wireless kan. Both require station to listen from transmission. Both ni CSMACA dan CMSACD. Both require station to listen to transmission and must wait until the medium is available. Okay. CSMACD nodes can immediately transmit. Okay, sebab dia redah je. Kalau ada collision dia akan detect. Faham tak? If there is collision, it will be detected and the node will temporarily stop transmitting. Dia boleh hantar berhenti tengah jalan. CMACA dia cuba elakkan supaya tak ada collision. So dia takkan terus hantar. Okay, 802.11 wireless radio are not capable of detect a collision, cannot listen and transmit at the same time during their transmission. That's why dia tak pakai CMACD, kan? So dia pakai CSMACA. For this reason, 2.11 wireless networking use CSMACA instead of CSMCD to try to avoid collision. CSMA maksudnya Carrier Sense Multiple Access. CSMA stand for Carrier Sense Multiple Access. So with collision detection CD lah, with collision avoidance CA. So yang ni wired, yang ni wireless, kan? 2.3 and 2.11. Okay. So kalau kita tengok dulu CSMCD, sender first sense the medium to determine whether it's idle or busy. Tapi dia sense juga kan, medium boleh hantar tak boleh hantar. Kalau idle dia akan hantar, kalau busy dia relax dulu bagi orang settle. So if the found busy, the sender refrain from transmitting packet. If the medium is idle, the sender can initiate data transmission. Okay, so CSMCD require that sender aware of collision. So instead CSMCA attempt to avoid collision in the first place. Tak terus hantar lah. Initial access method for wired LAN half duplex mode. For example, hub and coax cable. Coaxial cable ni contoh kamu nak tengok kamu tengok dulu-dulu TV kan ada antena kan? Antena dia macam tu ataupun ni wire nak cucuk daripada piring Astro tu dengan transmitter dia, apa nama, modulator dia kan, kan dengan box dia kan lebih kurang kan, coaxial cable lah, coaxial cable. So procedure, listen to media and wait until it is free. No one else is talking. Wait a random back off time. Dia ada random back off time. Okay. Then start talking selepas dah wait for random back off time. So advantages is fairly simple to implement. Senang je and functional scheme that works. Work lah. Okay. Tapi ada cons dia, cannot recover from collision. So kena hantar semula. So habis masa lah. Okay. So an efficient waste of medium time. Tak apa, sekejap je laju kan. So, kita tengok dekat YouTube ni. Mana YouTube ni? Gambar ke ni? Show. Sekat lah. Let's check it out. Tambah sound kan.
CodeScan Shield enables users to guarantee error-free code and 100% adherence to.
Have you ever wondered how computers send data on the network without interfering with the data from other computers? Especially if the network has a lot of computers that are sending and receiving data at the same time. I mean, you would think that there would be a lot of collisions happening. I mean, there should be data packets that are constantly smacking into each other in all that network traffic. But even though collisions do happen from time to time, especially on older networks, a technology was developed to not only help avoid collisions, but also to respond correctly if a collision does happen. And this technology is called CSMA-CD, which stands for Carrier Sense Multiple Access Collision Detection. And this is the access method used on early Ethernet networks. And when I mean early, I'm referring to half-duplex networks that utilized coaxial cable and earlier versions of twisted pair cable. Now, CSMA-CD basically works by each computer first sensing if the wire is idle, and if it is, it sends its data, therefore avoiding any collisions. But if you have two computers trying to send data at the same time, a collision will happen, And if a collision happens, the computers will wait a random amount of time and retries to send their data. So as an example, here we have a network with 4 computers, and these computers are all sharing a common transmission medium, which is a cable. And this cable must be regulated so that no computers send data at the same time, which would result in a collision. And when a collision happens, it causes data loss or data corruption. So let's say that this computer here wants to send data. So first it will sense or listen if there is any traffic on the cable. And if it senses traffic, the computer will wait until the cable is idle to send its data. But once it senses that there is no traffic, it'll go ahead and send its data. And as it's sending its data, it will listen for a collision. And if it doesn't sense a collision, it knows that the data was successfully sent. Now, in another scenario, if 2 computers are ready to send their data and they both notice that the cable is idle, then both computers will go ahead and transmit their data at the same time. But when this happens, a collision occurs. And when the computers that are sending the data detect a collision, they immediately stop sending the data and instead will transmit a jamming signal out on the network. And this jamming signal is what notifies all the other computers on the network that a collision has happened. And after the computers receive this jamming signal, the 2 computers that caused the collision will wait a random amount of time before they send their data again. And the wait time must be random to each computer so that the collision doesn't happen again. So as I stated before, CSMA-CD was used on early Ethernet networks, and it isn't as relevant today due to the advancement in network technology. It was only relevant in the older half-duplex networks, where data communicates in both directions, but not at the same time. Today, we use full duplex networks, where data can communicate in both directions at the same time. And there is also CSMA-CA, which stands for Carrier Sense Multiple Access with Collision Avoidance. Now this is the access method that's used for carrier transmission in wireless networks. Because just like wired networks, wireless networks need to avoid collisions as well. So this is how it works. So when a computer wants to send data on a wireless network, it really can't sense or hear if there are any collisions on the network because there's no cable involved. So instead, it does its best to avoid collisions altogether. So in this method, when a computer wants to send data, it'll first sense if there are any other transmissions happening. And if it detects any other transmissions, it'll wait a short amount of time before checking the channel again. And when it checks the channel again, and if it doesn't sense any transmission, it'll wait a short random amount of time, and then it'll go ahead and send its data. Then once the destination device receives the data, it will respond to the sending computer with an acknowledgement, informing the sender that it has received the data. But if the sending computer does not receive an acknowledgement from the destination, it will assume that it did not get the data and it will start the process all over again. Now, another method that CSMA-CA uses to avoid collisions is the optional RTS-CTS protocol, which stands for Ready to Send, Clear to Send. Now, this is an optional protocol that's used with CSMA-CA on wireless networks. This protocol enables a computer to send out an RTS or ready-to-send signal to the wireless access point requesting for an opportunity to send out its data. And if the wireless access point grants this request, the access point will temporarily stop all other communication on the network, and then it'll respond back to the computer with a CTS or clear to send signal, which tells the computer to go ahead and send its data. So in this protocol, the wireless access point is basically the traffic controller on the wireless network.
Jangan ada kelam pula dah. Antara cuma 11-11. Okey, clear tak? Clear kan? Boleh masuk channel dia. Check balik kan? Alright. Okay, next. Kita tengok improvement from CSMA are also used for hub-based internet. Okay, dia dah mention tadi kan? Half duplex kan? So procedure, listen to media and wait until it is free. Then start talking but listen to see if someone else start talking to. CSMCD kan? So if a collision occurs, stop and then start talking after a random back off time. Kalau ada berlaku pelanggaran tadi, dua-dua akan terima satu time yang di random, tak sama lah kan. So dia akan dia orang akan hantar ikut random time tu. So dia akan ada masa back off start kan. Advantages more efficient than basic SSMA. So this advantage require ability to detect collision ataupun voltage spike. Okay, as I mentioned dalam video this, SMCA CD was used in now obsolete shared media internet variant 10/5, 10/2, and in the early version of twisted pair internet which use repeater hubs. Pakai switch kan? Modern internet networks built with switches and full duplex connection no longer need to use CSMA-CD because each internet segment or connection domain is now isolated. CSMA-CD is still supported for backward compatibility and for half duplex connection. Ni lama-lama kan? Ni ini coax cable kan? Macam pipe kan? Kan? Macam best lah dia punya tu kan? Ni hub. Saya ada juga hub. Kalau nak main boleh lah, nak check pakai apa nama Wireshark ke kan, sebab dia akan duplicate frame. Dia akan copy frame hantar ke port satu lagi, kepada semua port. Can we borrow media access method from fixed network to be used in wireless network? Problem in wireless network, radio cannot usually transmit and receive at the same time kan. Yang kedua, problem dia signal strength decrease proportionally to the square of the distance or even more. The sender would apply CS and CD, but the collision happen at the receiver. It might be the case that the sender cannot hear the collision. For example, CD collision detection does not work. Furthermore, CS might not work. For example, a terminal is hidden. And then kita teruskan dengan CSMCA sebab CSMCD dah tak mampu kan. Okay, tak mampu kan. Absolute. Carrier sense devices sense the carrier to see if it is clear. Multiple access ni mana device access the carrier at the same time. Ni dia tunjuk apa masuk carrier sense, apa masuk multiple access. And then collision avoidance ni apa? The sender before transmitting contact the receiver and ask for the acknowledgement. If not, receive the request is repeated after a random time interval. Kan? Ni kedudukan dia dalam apa nama OSI layer kita lah. Kan? Tadi kan layer kedua kan ada dua logical link LLC. Okay, MAC kat sini kita letak quotation free, bagi pula kan. Dia ada point coordination function dengan distributed coordination function DCF. Okay. Ini dua ni kita panggil quotation base lah. Bawah adalah physical layer. Okay, so types of CSMA-CA according to the IEEE 2.11 2012 standard, there are three medium access method: distributed coordination function ataupun DCF, the fundamental and mandatory access method of the 2.11 standard has optional RTS, CTS yang tadi kita tengok kan. Ready to send, kalau ready, kalau clear dia akan stop semua, dia akan hantar message clear to send CTS. Okay. If many stations attempt to communicate at the same time, many collisions will occur, which will lower the available bandwidth and possibly lead to congestive collapse. So no QoS guarantee, no priority traffic. Okay, dekat point coordination function, dekat layer tadi kan, ada optional access method. Ataupun kita pakai dua-dua ni. Dua ni hybrid coordination function ataupun HCF. Introduced in 2.11e. 11e Wi-Fi apa tu? Wi-Fi 5 ke? Tak ingat lah. Okay, so HCF ni for delay sensitive applications such as voice over wireless LAN and streaming multimedia. Ni guna nak streaming kita punya YouTube lah kot, kan? Okay, kita tengok dekat layer sub layer tadi kan, DCF, Distributed Coordination Function, DCF, default method and mandatory method for 2.11 access, contention-based method determine who gets to transmit on the wireless media access. So it will utilize multiple checks and balance to try to minimize collision. Allow for an 2.11 radio to transmit a single frame. After transmitting a frame, the 2.11 station must contend for the medium again before transmitting another frame. Okay, so tengok dia punya flowchart dia. Okay, distributed coordination function DCF, dia akan wait for frame to transmit first. Kalau medium, baru dia akan medium. Kalau idle, dia akan hantar. Tak, dia tak hantar lagi. Dia wait IFS. IFS ni apa? Interframe space. Okay. Kalau still idle, baru dia hantar. Kalau tak idle, ada traffic, so dia akan wait anti current transmission end. Okay, so dia akan wait IFS. Ada tak idle lagi, so dia akan ulang wait anti current transmission end. Dia akan wait IFS banyak kali. Selagi traffic tak berhenti, kan, tak idle, so dia akan wait ulang je. Kat sini dia akan ulang. Kalau idle, dia dah boleh hantar, tapi sebenarnya dia kena ada back off time dulu. Kan, exponential back off while medium. Idle tak terus transmit, selepas habis time tu back off, baru dia akan transmit. Bila dah habis transmit, dia akan wait for frame to transmit balik. Sama kan? Right. So IFS ada tiga. Short interframe space, PCF interframe space dengan ni DCF interframe space. IFS ni ada dua tempat kan. Sama ada yang first dah boleh hantar atau second tak boleh hantar, dia wait tu dia akan dia akan ulang. Okay, untuk interframe mag timing dia ada dalam kalau kita bahagilah, kita bahagi dia punya frame kita ni. Okay, so masa ni kalau ikut ni masa kan, so dia akan ada DIFS dulu. Kalau ada biji medium, so dia akan interframe, and then dah ada, kalau dah boleh hantar, so dia akan ada back off window. So that ni adalah next frame. So there are four main component of DCF, IFS ataupun interframe frame, duration ID, carrier send and random back off timer. Okay. So interframe space is a period of time that exists between transmission of wireless frame. There are 6 types of interframe space which are listed here in order to shortest to longest. Paling kecil ada RFS ataupun highest priority, tapi dia paling short lah, kan. Frame paling short, nombor 2, short interframe space, second highest priority, PCF interframe, PIFS tadi, middle priority dia middle, and then lowest priority is DCF interframe space. Okay, so frame-frame lain yang ada yang lebih panjang adalah arbitrary interframe space, Yang ni guna untuk QoS station. Extended interface space used after receipt of corrupted frame. Kalau ada corrupted frame. The most common interframe space used are the SIFS and DIFS. Saya on mic tak? On kan?
On.
Okay, the two most common interframe space used are the SIFS and DIFS, as shown below. Yang bawah ni. The SCK frame. SCK frame is the highest priority frame, and the use of SIF ensure that it will transmit first, okay, before any other type of 2.11. The other 2.11 frame follow a longer period of time called DIFS. SIF dulu kan, ICF dengan DCF. Ingat tu. Okay, short interframe spacing, SIF highest priority, PIFF, PCF, medium priority dan paling lowest priority DI atau DCF, IFS. Okay, so dia punya berapa slot time ada sini kan. Okay, kenapa SIF yang ni untuk SCK CTS tadi kan. So akan untuk polar response, SIF time and slot time are fixed per physical layer dalam masa 10 microsecond saja ataupun 20 microsecond in PSSS. Okay, untuk PCFF, PIFS, PCF, IFS, medium priority for time bounded service using PCF. So PIFS time sama dengan SIF time, ini tambah dengan slot time saja. Tapi dia medium lah kan. Ada okey sikit lah high daripada DCF, IFS. So yang rendah sikit lowest priority for asynchronous data service. So dia sama dengan yang tadi. DIFS time sama dengan SIF time. Yang ni tambah dengan 2 kali slot time. Right. So boleh nampak kan dia punya banyak, dia punya panjang dia kan. Masa dia ambil untuk SIF, PIF dengan DIFS after medium busy. Okay, priority yang tadi mana paling tinggi? SIF kan. PIF medium and then lowest is DIF. Priority dia lowest. Okay, so tiap-tiap ni tadi kita tengok 10 microsecond untuk SIF. Untuk slot biasanya 20 microsecond. Untuk B, untuk 2.11a 9 microsecond, 60 microsecond. Okay, untuk PIFS dalam 30 microsecond, kalau A 25 microsecond. Kalau di ICFF lagi banyak masa dia pakai kan, 50 microsecond dalam 11 A 2.11a dalam 34 microsecond. Okay, so minimum untuk contention Windows adalah 32 slot untuk 11B, so 11A 15 slot. So yang standard FSF bila ada nak kena buat correction ataupun bila ada masalah, so dia depend on variable. Okay, untuk fee yang kedua, duration ID. So this is one of field in the MAC header of an AO 2.11 frame. All station monitor this field. Okay, this field untuk ID ni ataupun duration ID ni. It indicate how long the RF medium will be busy before another station can content for the medium. Tu penting tu, dia nak tengok berapa banyak yang dia akan masa diperlukan untuk, dan dia printkan dekat ID dalam frame ni. So duration ID field contains a value from 0 to 32,767. Kan? Okay, the duration ID value represent the time, the time in microsecond that is required to transmit an active frame exchange process so that the other radios do not interrupt the process. A client that is transmitting the data frame calculate times to transmit this frame to the AP or to the client if an AP. So dia akan returning ACK, the time in between frame ataupun IFS, interframe spacing or session update. Dia NAV, ada satu lagi nama dia NAV. Yang ni adalah timer, network allocation vector timer. Example, katakanlah Mata ni nak sending frame to Josh. Mata sini nak hantar kepada Josh. So selain daripada tu ada Vivian. So Vivian also receive frame with NAV sama dengan 10 microsecond. So NAV ni penting, so dia tahu Vivian takkan hantar dalam masa 10 second, dia takkan hantar. Boleh? Okay, yang ketiga ID field dia adalah carrier sense dalam dalam frame kita tu. The first step that at auto.11 SMS is device need to begin transmitting is to perform a carrier sense. Okay, mula-mula sekali dia kena sense dulu network ada tak ada, boleh hantar tak boleh hantar. Nak tengok busy ataupun idle. This is a check to see whether the medium is busy. On virtual carrier sense, layer 2 carrier sense. Okay, virtual carrier sense use a timer mechanism known as a NAV tadilah. Listening radio listen a frame transmission from another station. Is look at the header of the frame and determine whether the duration ID field tadi contain a duration value or an ID value. Okay, if the field contain duration value, the listener akan set an AV timer. Kalau dia adalah ID value, so dia bukan duration. So the listening station we then use the NAV as a countdown timer, knowing that the RF medium should be busy until the countdown reach 0. The process essentially allows the transmitter at 2.11 radio to notify the other station that the medium will be busy for a period of time ataupun duration ataupun ID value. Okay, duration/ID value. The duration that are not transmitted listen and hear the duration/ID, set a countdown timer NAV and wait until the timer hit 0 before they can contend for the medium and eventually transmit on the medium. A station cannot contend for the medium until its NAV timer is 0, nor can a station transmit on the medium if NAV timer is set a non-zero value. Okay, clear? Clear tak? Sikit lagi.
Yeah.
Ada lagi 20 slide. And second is physical carrier sense. Dekat layer 1, carrier sense. Second, carrier sense method in case a station did not hear the other transmitter and was therefore unable to read the duration/ID field and set its NAV timer in layer 2 carrier sense. Physical carrier sensing is performed constantly by all stations that are not transmitting or receiving. When station perform a physical carrier sense, it is actually listening to the channel to see whether any other transmitter are taking up the channel. Physical carrier sense has two purposes to determine whether a frame transmission is inbound for a station to receive. If the medium is busy, the radio will attempt to synchronize with the transmission. To determine whether the medium is busy before transmitting is known as a clear channel assessment CCA. CCA involves listening for RF transmission at the physical layer. The medium must be clear before a station can transmit. So it is important to understand that both virtual carrier sense and physical carrier sense are always happening at the same time. Virtual carrier sense is a layer 2 line of defense, while physical carrier sense is layer 1 line of defense. If one line of defense fails, hopefully the other will prevent collision from occurring. Boleh jadi kan? Okey, yang keempat dalam frame kita ada random pula dah. Kan, random backoff timer. Okey, yang nak tengok berapa banyak yang akan kena backoff kan, tak boleh hantar apa-apa. An 2.11 session may contend for the medium during a window of the time known as the backoff timer. The station selects a random backoff timer using a pseudo-random backoff algorithm. The station choose a random number from a range called a contention windows. Bukan senang-senang je dia nak bagi nombor random kan. Dia ada cara dia. Ada ada algorithm dia kan. After the random number is chosen, the number is multiplied by the slot time value. Kali 2 pula kan. Slot time size are dependent on the physical layer specified, PSY, in use DSS or FDM, etc. The random backoff timer is the final timer used by a station before it transmit. When the backoff timer is equal to 0, sebenarnya tak ada backoff lah. Kan? Boleh client can react the channel and effectively begin transmitting. Okay, ni contoh Vivian and Josh might want to transmit frame when mata transmission is complete. Kan? Dua-dua nak hantar tapi dua-dua tengah tunggu mata punya transmission complete. Both stations should have the same NAV value and both will physically send when the medium is ada. That's why kita perlu back off. Maksudnya Vivian dapat line, Josh akan dapat line kan. So kalau tak dua-dua tunggu nanti hantar collision juga. Betul tak? There is a high probability that both stations will attempt to transmit when the medium becomes idle, causing a collision. To avoid this situation, DCF use a random backoff timer. The random backoff algorithm randomly select a value from 0 to contention windows ataupun CW, contention windows CW value. We will ready to transmit her and every timer has decremented to 0 and the PSY also indicate the value is idle. We will select a random backoff timer. In this case, CW is 4. And with the selected number of slot times before transmitting. After 4 slot times pass, Vivian can transmit. But what if just station has a random backup timer 2 time slot? Vivian update the NAV with that same value. Sebab sempat lah kalau dia dapat 2. Seorang dapat 4, seorang dapat 2 kan. Okay. So Vivian must wait for the NAV to decremented to 0 and her physical to report that. Even that is available again before she can resume her backoff. In this example, we must wait an additional 2 slot time before attempting to transmit. Ni macam tadi kan. Kalau kata dah lepas, so dia akan wait until current transmission and wait. Dia ulang balik yang tadi kan. Ni yang tadi kan. Okay. Daripada DCF tadi, kita ada PCF. Point Coordination Function. In addition to DCF, IEEE 802.11 2012 juga, okay, this standard define an additional optional media access method known as Point Coordination Function ataupun PCF. This access method is a form of pooling. The AP perform the function of the point coordinators. PC because an AP is taking the role of the point coordinator. The PCF medium access method will work in only a basic service set ataupun BSS. PCF cannot be utilized in an ad hoc network. Kenapa? Because no AP exists in an independent basic service set ataupun IBSS. Because pooling is performed from a central device, PCF provide manage access to the medium. Okay, bagaimana walaupun bagaimanapun apa nama? PCF was never adopted by WLAN vendors. In PCF, the access point briefly take control of the media and pulls the client in order for PCF to be used. Both the AP and the station must support it. If PCF is enabled, DCF will still function. The AP will alternate between PCF mode and DCF mode. While the AP is functioning in PCF mode, that time is known as the contention free period ataupun CFP. During this CFP, the AP pulls only client in the PCF mode about their intention to send data. This method of prioritizing client. While the AP is functioning in DCF mode, that time is known as the contention period ataupun CP saja. Okay, the 802.11 equality of service amendment added a new coordination function to 802.11 medium coordination known as hybrid coordination function. Okay, nak ganti DCF dengan PCF, dia buat hybrid. Betul? So HCF combine capability from both DCF and PCF and add enhancement to them to create two channel access method. Satu dipanggil ADCAR, enhanced distributed channel access. Satu lagi HCCAR. Okay, HCF control channel access. Okay, apa HCF buat? DCF and PCF medium contention mechanism discussed earlier allow for an 802.11 radio to transmit a single frame. After transmitting a frame, the 802.11 transmit station must contend for the medium again before transmitting another frame. SCF define the ability for an 802.11 radio to send multiple frames when transmitting on the RF medium. When an SCF compliant radio content for the medium, it receives an allotted amount of time to send frame. This period of time is called the transmit opportunity ataupun TXOP. Transmit opportunity, TX opportunity, OP. During this TXOP, an 802.11 radio may send multiple frame in what is called a frame burst. Short interference space ataupun SIF tadi is used between each frame sebab dia parity dia tinggi kan. So to ensure that no other radio transmit during the frame burst. Right. So enhanced distributed channel access car tadi kan is a wireless media access method that provides differentiated access that direct traffic to 4 access category QoS priority queue. So ADCA is a extension of DCA. DCF, the ADCA medium access method prioritize traffic using priority tags that are identical to 2.1 D priority tags. So priority tags provides a mechanism for implementing QoS at the MAC level macam AO2.1 Q tadi 1D priority 1Q header kan. Different classes of service are represented in 3-bit user priority field is in and ataupun AO2.1 Q header added to the internet frame. Ni wired. AO2.1D ni apa buat? So enable priority queuing, enable some internet frame to the forwarded ahead of other within a switched internet network. Figure below depicts apa nama AO2.1D priority tags from the internet sites sebelum internet atas ni that used to direct traffic to access category queue. So dia punya AP kat bawah lah kan. Yang atas ni wired. So dia bagi pula ADCA ni define pada 4 access category based to the 8 UPs. Okay. The 4 access category from lowest priority to highest SCBK, SCBE, SCBI video. Kalau untuk buat SCVO. So for highest adalah background. Background highest lah. Bukan. Voice highest. Voice. Sound dulu highest. Video nombor 2. Best effort dan background lowest. Terbalik saya salah faham. Lowest. Okay. Yang highest priority voice dulu. That's why kalau kata kadang-kadang kita tengok voice keluar dulu kan. For each access category and enhanced version of DCF known as enhanced distributed channel access function is used to contend for the TXOP. Frame with the highest priority access category have the lowest backup value and therefore are more likely to get a TXOP. Tadi ADCA ni HCCA pula. SCF control channel access ni pakai hybrid ni kan. Is a wireless media. HCCA is a wireless media access. Okay, wireless media access method. Okay, that use a QoS aware centralized coordinator known as a hybrid coordinator. Atau HC which operate differently than the point coordinator in the PCF network. The C is built into the AP and has a higher priority of access to the wireless medium. Using this higher priority level, it can allocate the SOPs to itself and other station to provide a limited duration control access phase ataupun CAA. Bukan nasi ya. Providing contention free transfer of QoS data. Tak ada nasi, tak ada situ. Habis. CSMA, CA, CMSA, CD. Habis semua. Dia punya wireless semua masuk sekali tadi kan. Okay, kita nak tengok yang multiple access with collision avoidance. Ya, ini yang RCS CTA sama tak? Sama. Okay. Multiple access with collision avoidance, MACA. stand for multiple access with collision avoidance designed to solve problem of hidden terminal found. Ni kalau ada masalah hidden terminal je. Kan? Use in ad hoc network. Okay, tak ada AP. Ni tak pakai AP where SMSCA with RTS and CTS not suitable and those and CS not needed. Ni kalau kamu pakai ad hoc. Kan? Laptop dengan laptop kamu kan? So tak ada AP. Okay, use RTS, CTS short signaling packet mechanism similar to RCS MACA to avoid collision. So RTS ni tadi yang kita tengok ni adalah request to send. Sender request the right to send from a receiver with a short RTS packet before it send a data packet. CTF kalau dia boleh hantar clear, so dia akan hantar dekat sender clear to send, baru sender akan hantar packet ataupun frame. So packet ke frame? Sama lah, dalam frame tu ada packet kan. Tapi kita sebut packet pun boleh, frame pun boleh. Frame tu sekali dengan header trailer dia lah kan. Frame lah, okay, hantar frame besar sikit kan. Dalam dia packet tu lah. Kita nak hantar packet kena ada frame. Nah. So CTS adalah clear to send. The receiver grants the right to send as soon as it's ready to receive. Meanwhile, note that here RTS should remain silent to avoid conflict with CTS. Betul. Note that here CTS should keep silent until the data transmission is complete. So signaling packet contains server address, receiver address, packet sizes. Okay. Ni contoh dia. MACA avoid the problem of hidden terminal. Hidden terminal ni apa? Kata A dengan C nak hantar dekat B. A send RTS first, C wait after receiving CTF from B. So MACA avoid the problem of exposed terminal. B want to send to A. C to another terminal. Now C does not have to wait for it cannot receive CTF from A. Itu dia punya solution dia kan. Okay. Tak faham juga. So hidden node problem ni, A send to RTS to B, but C cannot listen. Nampak tak? Dia dah hilang kan. Node dia tak sampai kat dia. Sebab apa? Contoh kat sini out of range lah. Kan? Dia punya tak sampai, coverage tak sampai kan. C nak hantar ke B, tapi dah hilang kan. If C send at the same time with A, collision will occur at B. Collision untuk RTS ni sama RTS boleh collision. Betul tak? Okay, upon receiving RTS from A, B respond with CTS. Now C can hear the CTF sent by B to A signs it within range. Okay, within the RTS and CTF, there is information about the data will be sent by the initiated node, node A in this example, in the form of duration. Node C will refrain from accessing the network using the duration information. So ni adalah MACA, multiple access with collision avoidance. Dia collision RTS tu yang collision kan, bukan hantar data tu yang collision. Upon receiving the CTF from B node, mungkin jadi data dengan RTS pula yang collision kan. Dia dah dengar hantar tapi dia tak dengar, dia ingatkan tak ada, dia ingatkan idle. Faham tak? Sebab dia tak ada, dia signal tak sampai, dia ingatkan network dia idle sekarang kan. Dia pun hantar RTS. Ini tengah hantar data, pun boleh jadi collision. Kan? Okay. Punca ada C lah, C ni hilang dia punya hidden node kan. Once the CTF from B node A then send the actual data, this method can avoid collision due to the hidden node problem in ad hoc network. Okay. In wireless network, the exposed node problem occurs when a node is prevented from sending packet to other node because of co-channel interference with a neighboring transmitter. Consider an example of 4 nodes labeled R1, S1, S2, and R2, where the two receiver R2 and R1 and R2 are out of range. R1 and R2 out of range of each other, yet the two transmitter S1 and S2 in the middle are in range of each other. Here is a transmission between S1 and R2. S1 dengan R1, current transmit. S2 dengan R2, dia nak submit kan. No, S2 is prevented from transmitting to R2. S2 dia tak boleh hantar kepada R2 as it conclude after carrier sense that it will interfere with transmission by its neighbor S2. However, note that R2 could still receive the transmission S2 without interfering because it is out of range of S1. Dia tak boleh hantar. Kamu jangan tengok benda ni boleh hantar sebab dia laluan tak sama. Tak. Dia pakai wireless yang sama. Kan, kalau dia hantar juga akan collision because wireless dia tak nampak, dia boleh jadi kat mana-mana pun boleh jadi kan. Wired senang, dia ini lalu jalan lain, ini lalu jalan lain, maksudnya line berbeza, bolehlah hantar kan. Maksudnya network berbeza lah. Tapi sekarang kita dalam network yang sama. Okay. If a node hears no response to an overheard RTS, then it may assume that the intended recipient of the RTS is either down or out of range. Kemungkinan out of range atau kemungkinan down kan. Okay. So ni banyak lagi nak hantar ni. Kan. So dia akan ada block from transmission. Yang kat luar tak boleh, dia akan block supaya tak berlaku collision. Right. So station C has recently sent traffic to station A. It knows how much power is required to reach A. If C overhears station A responding to with the test to the third station B, so then C need to remain completely silent for the required interval. It need only limit its transmitter power to say, okay, so sebab dia wireless, so dia mean power lah. Hantar banyak mana kan, 20 disable below the level needed to reach A. Bukan, W ni nanti bawa wireless. During this time, it would be free to transmit to any station that it could reach with that reduced over level because its signal A, okay, would be overridden by B signal. This is analogous to the people that got the party continuing their conversation in whisper instead of stopping completely while their neighbor are having conversation. Semua orang tengah cakap kan. Okay, untuk wireless, okay, ni baru last kali wireless. Okay, tambah W je untuk wireless. Tapi wired pun confuse kan, W ni mungkin jadi wired kan. Tapi kita dah pakai W LAN, wireless LAN. Tak kata W LAN tu wired LAN kan. So kita faham macam itulah W wireless. Okay. Dalam banyak-banyak A to Z, W lah number yang double kan. Betul? W. Saya ada teka-teki ya. Dalam banyak-banyak haiwan apa yang 2 huruf je? Mana? Dekat chat ke? Kau jawab kat mana? Telegram? Tak ada pun. Kau semua dah tidur ni? Lecture biasa lah.
Udang. Ada
Okey, jawapan tu.
Buat udang.
Kan?
Easy lah sir.
Easy lah. Tengok TikTok lah tu. Saya dapat dari TikTok tak? Kan? Saja selingan. Okey, kita masuk Macau. Macau pula dah negara kan. Macau has been developed as improvement to Macau protocol and used in ad hoc networks. So tadi RTS, CTS ada RTS ready to send, CTS clear to send. Lepas tu frame kita data ataupun ACK message are exchange between terminal. So no carrier sense, no collision detection. So collision avoidance, sender send RTS. Okay, macam mana nak avoid Sender send RTS, receiver send CTS, sender send DS, sender send data. Okay, dia hantar dua benda, DS dengan data. Receiver akan send ACK, station hearing DS defer until end of data transmission. So backoff as mechanism ada juga exponential backoff with significant change for improving fairness and throughput. So dia pakai backoff. Okay, so kita tengok macam mana berlaku. Assume that node A, mana node A ni? Jauh tengah. Kalau kita start A sini kan, A kat tengah. Node A has data to transfer to B. A nak hantar ke B sebelah je. Node A initiate the process by sending a request to send. Betul? Okay, so to B, the destination node B reply with, okay, aku bagi kau CTF. Clear to send. After receiving CTF, node A send data. Tak ada masalah kan? After successful section, node B replies with acknowledgement. Ni tak ada apa-apa. Dia akan bagi SCK. Okay. If node A has to send more than one data fragment, it has to wait a random time. So dia ada lagi nak hantar, tak habis lagi. So dia tak boleh terus hantar, dia kena ada backoff time. Random backoff time. After each successful data transfer and complete with adjacent nodes for medium using RTS, CTS mechanism. Ni masa dia ada 9, 10, 8, 4, 4, 4, 2. Kan? Okay, any node overhearing and RTS frame, semua akan dengar. Betul? Sebab dia kan wireless, semua boleh dengar. Ada RTS, DTS, siapa yang hantar, siapa yang boleh. Okay. Refrain from sending anything until CTF is received or after waiting a certain time is captured RTS not followed by CTF. The maximum waiting time is the RTS propagation time and the destination node turnaround time. Okay. Dia kena penting lah RTS dengan CTS ni semua orang boleh dengar. Data dia akan buat bagi B saja dengar. Betul? Any nodes, node C and E, C mana C? C dengan E, overhearing a CTF frame, refrain from sending anything for the time until the data frame and execute should have been received. So dia akan solving the hidden terminal problem yang kalau kata tak luar kawasan pun plus a random time. So both the RTS and CTS frame contain information about the length of the data frame. Hence, a node use that information to estimate the time for the data transmission completion. So before sending a long data frame, kan dia ada banyak nak hantar. Node A send a short data sending frame ataupun DS, which provide information about the length of data frame. DS and the data frame. Every sender that over here, this frame knows that RTS CTS exchange was successfully and over. Kalau dapat DS maksudnya RTS CTS successful and overheading station node F lah. Might have received RTS and DS but not CTF. Dia ada terima RTS tapi tak terima CTF. Tapi dia terima DS juga. Default information until after the execution frame should have been received plus a random time. So dia akan dapat random time sebab walaupun dia tak ada CTS tapi dia ada DS, maksudnya DS ni dia tahu lah successful. Kalau tak dapat DS pun dia tahu RTS dengan CTS dapat, so maksudnya dia tahu adalah successful secara sendiri. Okay, so dapatlah random time tadi, so takkan berlaku collision kan, walaupun dia cannot listen anything anymore kan. So masa dia ada masa untuk hear lagi. Lepas habis backup time, dia akan kembali hear. Bukan kembali send. Dia takkan sense. Dia takkan sense selagi dia tak ada dapat idle signal. Dia tengok punya signal dia idle. Kecuali dia memang dia apa nama out of signal. Kalau out of signal dia nak send kat siapa? Betul tak? Dia send je tapi tak ada siapa-siapa terima kan. Itu. Kemungkinan dia tak ada terima, tiba-tiba dia nak send. Dia takkan send lah. Lagi dia tak ada apa nama tak jumpa CTS, DTS ni kan. Okay, so dia kena hear juga. Tapi kalau yang bau-bau up memang tak ada siapa-siapa send, dia akan cuba send juga kan. Okay. So dia cuba send dengan RTS lah. RTS. So kita takut RTS ni dia send, tiba-tiba dia send kepada signal yang traffic yang tengah ada kan. Okay. So that's why kita ada back off time lagi, tambah lagi supaya dia ada plus time lagi supaya dia tak ada berlaku collision. So dia akan avoid collision. So that is a multiple SF with collision avoidance for wireless Macau. So last frame, last slide kita dah tengok tadi. Thank you for your time.